This is Mike Dubson from Project PhET, and I'm going to talk to you today about the simulation projectile motion. In this simulation, we have a cannon, and I can set the initial angle of the cannon. I can also set the initial speed of the projectile. I can also set the elevation and X position of the cannon. Let me show you a couple of things I use this simulation for during lecture. Suppose I set the initial angle of the cannon to be 0 degrees. And I'll start with the elevation up at around 15 meters, nice and high. I'm going to fire the cannon with an initial speed of, say, 10 meters a second. Let's fire. And notice that it took 1.79 seconds to reach the ground. I'm now ask my students, suppose I increase the initial speed to, say, 16 meters a second. Will it now take longer to reach the ground, the same amount of time to reach the ground, or less time? I'd let the students discuss that for a little while and then vote with their clickers on the answer. And then let me answer the question experimentally by increasing the speed to 16 meters a second and firing. It still took exactly 1.79 seconds to reach the ground. Let me decrease the speed to, say, 5 meters a second. Still takes 1.79 meters a second. The point of this exercise is to show that the time to reach the ground is controlled entirely by the vertical motion, and it doesn't depend at all on the horizontal motion of the projectile. Another thing I like to show students with this simulation is the importance of air resistance. Let me turn on air resistance. Let me choose as my projectile a football. And then I'm going to fire the projectile at 30 meters a second, which is about as fast as a professional football quarterback can throw a football. Let me zoom out a little because this ball is going to go a long way. I fire. And let me measure the range of that projectile here. I can measure the range with this tape measure. It's about 65 meters, but notice the range is read out right here at the top as well. 65 meters is 70 yards. That's as far as a professional quarterback can throw a football. But now let me turn off air resistance and fire the football again. It goes a lot farther this time, about 50% farther. So the reason we ignore air resistance in freshman physics is not because it's a good assumption, but because it makes the mathematics a lot easier. There are lots of other nice features in projectile motion sim, but I'll let you find those on your own. Thanks a lot for using PhET Sims. Bye-bye.